Imagine you were sitting inside a closed-door conference room in Nevada. No media cameras, no live stream. Just a small group of carefully selected investors, engineers, and executives. On the stage stands Elon Musk. No suit, no microphone, just standing still next to a car with no charging cable, no exhaust pipe, and none of that familiar engine noise. And before he says a single word, someone in the room suddenly pours a half-finished bottle of drinking water from the table into the car. And that car starts. For years, people believed lithium-ion batteries were the future, that the electric vehicle race would be decided by whoever could produce battery cells that were cheaper, had higher capacity, and charged faster. Toyota bet on solid-state batteries. BMW poured billions of dollars into silicon anode technology. And Tesla, the company that once reshaped the entire industry, has been building a gigafactory empire across 3 continents to produce batteries. Everyone has been running in the same direction. But there is one question almost nobody dares to ask out loud. What if lithium batteries are not the final destination, but only a temporary stop along the way? And what if Elon Musk has known that for a very long time but never told anyone? That is the core of the story we are about to walk through today. Because on an ordinary morning, at a presentation that was originally scheduled as a routine investor meeting, a technology called Aqua Drive was unveiled by Tesla, and in less than 72 hours, it wiped out $29 billion in Saudi Aramco's market value, forced Norway to freeze its national lithium fund, and suddenly made more than 50,000 charging station projects across North America look meaningless. So what is this technology really? How does it work, and why did even companies that had already spent tens of billions of dollars on electric vehicles immediately begin adjusting their strategies? And more importantly, is this truly a turning point, or just another big show the world has seen too many times before? Those are the questions we're going to try to answer in this video. Before we go deeper into the story, if you enjoy detailed breakdowns like this about technology, energy, and the things quietly changing the world, then subscribe to the channel and turn on notifications right now so you do not miss any exciting new content. The silent crack in the battery empire. To understand why this event caused such a shock, we need to step back and look at the bigger picture of the electric vehicle industry over the past few years. From 2018 to 2023, the story of electric vehicles had almost one single narrative. Lithium-ion batteries were king. Every major investment, every national energy policy, every long-term strategy from automakers revolved around one central goal: how to make batteries better, cheaper, and in larger quantities. And for a long time, that strategy seemed right. Tesla proved that electric cars could be both high-performance and attractive enough for consumers to actually pay for them. GM, Ford, Volkswagen, Hyundai, everyone followed. Hundreds of billions of dollars flowed into lithium, cobalt, and rare earth mineral mining. Countries like Chile, Congo, and Indonesia suddenly became geopolitical centers of attention because they controlled the raw materials of the electric vehicle economy. But even while that machine was running at full speed, cracks had already started to appear. People just did not want to look directly at them. The first problem was infrastructure. Power grids in many parts of the United States, Europe, and especially emerging markets were never designed to handle millions of electric vehicles charging at the same time. Fast charging stations kept breaking down or becoming overloaded during peak hours. Waiting time became a real-world problem, not just a theoretical concern. Long road trips were still a genuine anxiety for most users. The second problem was mineral cost. Lithium, the so-called white gold of the 21st century, went through an extremely unpredictable price cycle. In 2022, the price of lithium carbonate rose by more than 500% compared with 2 years earlier. That meant battery production costs surged and profit margins on each electric vehicle became much thinner. The third problem, perhaps the least discussed but the most important strategically, was geopolitical dependence. China controls a major part of the rare earth mineral supply chain, from mining to processing and battery production. That puts Western automakers in a very vulnerable position, especially as trade tensions continue to rise. And behind the scenes, according to internal sources cited in later leaked documents, Tesla realized this problem earlier than most. An internal memo said to have circulated in late 2022 reportedly stated it bluntly, lithium is the single point of failure of the electric vehicle revolution. But to understand why that matters so much, we need to look at the core of the entire story, and that is how Aquadrive was actually born. Hydronova and the secret hidden in a line item. The story did not begin inside a shiny Tesla laboratory. It began in Tel Aviv. Inside a small startup, almost nobody had heard of Hydronova Systems Limited. Hydronova was not founded to build cars. Its original mission was military and maritime, to develop miniaturized water-splitting technology for long-range underwater drones. The core idea was to allow these underwater devices to generate their own hydrogen fuel from seawater while moving without large fuel tanks and without refueling from a mothership. This was a very specific military application with extremely demanding technical requirements, and they solved it. At the center of Hydronova's system was a device they called an ultrasonic splitter, a piezoelectric electronic membrane capable of vibrating at more than 22,000 cycles per second. At that frequency, the water molecules inside a sealed chamber began to break apart through a mechanism called cavitation, the creation and collapse of microscopic bubbles with enough localized pressure to split the chemical bonds between hydrogen and oxygen without traditional electrolysis. This might sound like a purely technical detail, but understand what it means in practical terms. In traditional electrolysis, you need to feed electricity into the system to split water, meaning you need an external energy source before you can create hydrogen. That is an inefficient loop. But Hydronova found a way to use mechanical vibration energy to trigger the reaction. And the energy used to create that vibration could come from the vehicle's own power generation system. Tesla quietly acquired Hydronova in 2021. No press release, no tweet, just a small line in the asset list of a shell company. On the surface, the deal looked no different from hundreds of small startup acquisitions Tesla had made over the past decade. But the Tesla engineering team sent into Hydronova immediately recognized something the startup's founders may not have fully appreciated. This technology was not just suitable for submarines. It could be miniaturized enough to fit inside a passenger car, and if that could be done, then the entire electric vehicle story would have to be rewritten. They named the project Aquadrive, and for the next 3 years, it was developed in complete secrecy. At first, it sounds simple. A vibrating machine breaks water apart to get hydrogen, then burns hydrogen to generate propulsion. But the small details in how each stage of that cycle is optimized are exactly what could change the entire game. How Aquadrive works and what makes it different. Let's get to the heart of this technology, but not in the way an engineer would explain it to you. Instead, let's explain it in a way that anyone can understand the real-world meaning. A car equipped with Aquadrive carries a 40-liter water tank. That is all the fuel you need. Inside the car, a graphene ceramic ultrasonic splitter, a self-healing piezoelectric membrane continuously vibrates at ultrasonic frequency, breaking water molecules apart and releasing hydrogen based on the vehicle's actual demand. There is no high-pressure hydrogen storage, which has always been the biggest safety concern with traditional hydrogen fuel vehicles. Instead, hydrogen is generated instantly and sent directly into a boron nitride microturbine combustion chamber, a material that can withstand temperatures above 2,200 degrees Celsius. Unlike a traditional internal combustion engine with pistons and a crankshaft, Aquadrive converts plasma pressure directly into torque through a rotating magnetic axial coil. No mechanical lag, no unnecessary friction. The output energy is smoothed by next-generation supercapacitor arrays, not batteries, with charging and discharging speeds up to 3,000 times faster than conventional lithium-ion cells, and without capacity degradation over time. The most impressive part may not be the direct performance, but how the system handles waste heat. Heat from the combustion chamber is not wasted, it's routed back through a steam compression loop, which both cools the combustion chamber and adds another 18% to total driving range. The only emission that exits the vehicle is water vapor. The overall result? More than 820 kilometers of range from a 40-liter tank. Refueling time under 90 seconds, all you need is clean water. A top speed of 189 kilometers per hour, limited by software rather than hardware. Operating cost around 0.7 US. Cents per mile lower than the cost of electric charging in many major markets. And total energy efficiency above 90%, a figure that no current battery system or fuel cell system can achieve. But what makes AquaDrive truly revolutionary is not these numbers, impressive as they are. The real game changer is what the system does not need. No lithium, no cobalt, no rare earth metals, no charging stations, no power grid. It does not depend on any part of the current electric vehicle economy's infrastructure. And with a water tank that can be refilled from any clean water source, tap water, filtered rainwater, even desalinated seawater, it can operate in places where traditional electric vehicles simply cannot reach. Rural regions, developing countries, and areas without a stable electrical grid. But no matter how good a technology sounds, it means nothing if it cannot be produced at massive scale, and this is where the story starts to get much more complicated. The forces that want to bury this technology. Not everyone welcomed AquaDrive. In fact, the reaction from multiple sides came almost immediately, and it was not normal scientific skepticism. It was organized, well-funded, and showed clear signs of major financial power standing behind it. Within 36 hours after the demonstration, a coalition of energy companies filed an emergency patent objection, not because they claimed the technology did not work, but because the official argument was that it would destabilize global energy security. This was an unusual legal argument, and even intellectual property experts noted that the lawsuit seemed designed more to delay than to win. In emails leaked afterward, the origin has not been fully verified, but the contents were cited by multiple media channels. Lobbyists connected to traditional energy corporations were reportedly discussing specific strategies to slow down, discredit, or neutralize the technology before it reached production scale. One line was quoted repeatedly, "This is not an engine, this is a weapon." Industrial rivals also reacted in their own way. Chinese automakers immediately began reverse engineering whatever could be inferred from the public technical details. Old academic papers related to ultrasonic cavitation and water separation suddenly saw an unusual surge in searches and downloads. Tesla's cybersecurity team tracked attempted system intrusions from groups they described as state-sponsored. And then there was an even harder-to-explain incident. A senior propulsion engineer involved in the final phase of AquaDrive testing was reportedly hospitalized with symptoms that some sources described as suggestive of poisoning. Nothing has been officially confirmed, but the test results this engineer had been finalizing, they disappeared. Whether you believe all of these details or not, they point to one important truth. AquaDrive is not just a technology event. It is an economic and geopolitical threat to many powers that have been established over decades. On the consumer side, the reaction was also fast, but in the opposite direction. Within 72 hours after the announcement, car dealerships in California, Germany, and South Korea recorded customer traffic dropping by nearly 40%. On online used car platforms, listings increased by 19% as many owners worried that their electric vehicles had become outdated overnight. Questions spread across social media: should I cancel my Model Y order, or should I wait for a water-powered car? This is what economists call a collapse of confidence. When a foundational technology is questioned, the entire ecosystem around it starts to freeze before any official decision is even made. And this is exactly when the race became more intense, because Tesla is not the only one trying to control the future. Who will control the next generation? If AquaDrive is real, and if it reaches mass production the way Tesla claims, then its geopolitical impact will be no less significant than the 20th century oil revolution, only in the opposite direction. Let's start with the most obvious loser: China. For years, Beijing has built a massive strategic advantage in the electric vehicle supply chain. It controls much of the refining of lithium, cobalt, and the rare earth minerals needed for batteries. It has exported electric vehicles and technology around the world at competitive prices, largely based on this supply chain advantage. If a technology that does not need any of those minerals becomes widely adopted, much of that geopolitical leverage disappears. But China is not just standing still. The response from Chinese automakers was immediate. Accelerate research into next-generation propulsion, pour money into domestic cavitation technology startups, and according to reports from the international academic community, launch a systematic effort to obtain aquadrive technology by any means possible. Japan reacted in a more interesting way. At the G7 Energy Summit shortly after the announcement, Tokyo presented the Water Mobility Framework, a policy proposal calling on governments around the world to begin rewriting vehicle classification laws and emission standards before the technology makes them obsolete. This was a smart move. Instead of waiting and getting left behind, Japan is trying to shape the rules of the new game before it officially begins. Toyota, the company, once mocked for being slow to move into electric vehicles, may suddenly look like the one that saw furthest ahead. It kept parallel research going on hydrogen technology, while most rivals poured all their resources into lithium batteries. A Toyota spokesperson after the aquadrive event was not defensive at all. We have been testing water-based propulsion systems in parallel since 2020. This was not an admission of defeat. It was a signal that they still have cards to play. Europe is in a difficult position. The entire continent has only recently agreed on a strict timeline to phase out internal combustion engines. Tens of billions of euros have been committed to electric charging infrastructure. If aquadrive truly becomes the standard, all of those investments will need to be reassessed. Meanwhile, Norway, once the model example of the transition to electric vehicles, quietly suspended its National Lithium Reserve Initiative and redirected investment toward desalination and hydrogen technologies. India sees the situation as a strategic opportunity. India's parliament passed an emergency hydrogen combustion tax credit in less than 48 hours after the announcement, not just to catch up with Tesla, but to try to skip the battery electric vehicle phase entirely and move straight into the next generation. Even Russia had a notable reaction, a short, dry press release from the Ministry of Defense. The Ministry of Defense is conducting a full review of water-based propulsion for military transport. No further explanation, no press conference. Just a cold signal. Major energy corporations are not standing still either. Shell, Chevron, and BP companies that had invested billions of dollars into electric charging networks over the past few years began pivoting toward pilot water hubs. Each station could filter, compress, and distribute hydrogen in under 6 minutes. This is a practical admission. If you cannot stop the change, try to control its infrastructure. Tesla, meanwhile, did not sit around waiting. Its entire supercharger division was restructured into Tesla Hydra Systems, with its first commercial product being mobile desalination pods integrated with hydrogen refueling capability, deployable anywhere on Earth. It is a clever move. Instead of trying to protect old infrastructure, Tesla is building new infrastructure. So in the end, the biggest question remains: is this technology truly powerful enough to change the future? What future is taking shape right in front of us? Let's set aside all the promises, all the marketing claims, and look directly at what could realistically happen over the next few years. Tesla has announced the Model H, its electric water vehicle variant, with pre-orders already open and deliveries expected in the fourth quarter of 2026. Within hours of pre-order opening, demand rose by more than 600%. That number matters not only commercially, but socially. People are not just ordering a car, they are betting on a different future. According to leaked internal forecasts, by 2027, around 47% of the Model 3 vehicles currently on the road could be upgraded to a water propulsion system through a standardized engine swap process. This matters because it means aquadrive would not require consumers to buy a completely new car, a huge psychological and financial barrier in any technological transition. But let's be honest about the challenges that remain. First, this technology has still not been tested at mass scale. An impressive demonstration is one thing. Millions of cars operating in real-world conditions, extreme temperatures, rough roads, maintenance by ordinary mechanics is something else entirely. The history of technology is full of things that looked perfect in the lab but ran into trouble once they reached the road. Second, the question of input water quality has not been fully answered. Tesla says the system can use tap water in emergency situations, but how would minerals and impurities in tap water affect the piezoelectric membrane over time? What would the real maintenance cost be? Third, and perhaps most important at a system level, is the question of freshwater as a resource. If hundreds of millions of vehicles around the world switch to purified water as fuel, what would the impact be on freshwater supplies in dry regions? Environmental scientists have already begun asking this question, and there is no clear answer yet. Fourth, from a regulatory standpoint, no transportation regulator in the world currently has safety standards for vehicles using on-demand hydrogen combustion without storage. Building a legal framework will take years, and during that time, commercial deployment will have to navigate a complicated legal maze. But even with all of these challenges, the impact on the industry landscape is already clear. The market value of lithium mining companies fell by an average of 23% in the first month after the announcement. Solid-state battery projects, once considered the next generation, suddenly became less attractive to investors. Panasonic, Tesla's longtime battery partner, released a striking statement. All future energy storage initiatives will remain chemistry neutral. The practical translation of that sentence is, they are no longer betting everything on lithium. On the consumer side, the deepest change may not be technological, but psychological. For years, the question around electric vehicles was always, when will they be good enough? With AquaDrive, that question has been replaced by a different one. Am I investing in the right thing? And once that question enters the consumer's mind, it is very hard to make it disappear. Let's pause for a moment and think about everything we have just gone through in this video. A company that was once laughed at for selling electric cars in 2008, a company that had to put its own cars up as collateral just to pay employees, that same company may now have created a technology that threatens to erase everything. The energy and auto industries have spent an entire century building, not by making electric cars better, but by asking whether electric cars are still the right answer. The most important thing about the AquaDrive story is not the technical specs, even though they are impressive. The most important thing is how it exposes a truth many people have felt, but few have dared to say out loud. The electric vehicle revolution was never as certain as it looked. It depended on too many variables: mineral prices, grid stability, charging infrastructure, supply chain geopolitics, and any one of those variables could change. AquaDrive, if it delivers what has been promised at real-world scale, would be the first time in modern history that a vehicle is truly free from centralized infrastructure. No dependence on someone selling you electricity. No dependence on someone mining minerals for you. Just water the thing that covers 71% of Earth's surface. But the future has never belonged simply to whoever has the best technology. It belongs to whoever can navigate politics, law, regulation, and resistance from forces that want to protect the status quo. And in this case, those forces are very powerful, very wealthy, and have decades of experience slowing down or burying technologies that threaten their interests. So the real question is not, does AquaDrive work? The real question is, who gets to decide whether the world is allowed to use it? And that is a question no one, not Tesla, not Musk, not any government can answer alone. We are standing at a very rare moment in technological history when an invention could truly change the global balance of power. But the outcome is still completely uncertain. Over the next few years, what happens inside boardrooms, patent courts, congressional hallways, and Tesla factories will decide whether this is the moment the future gets rewritten or just another chapter in the long story of delayed breakthroughs. And you, which side of this change are you on? Leave your thoughts in the comments below. If you believe AquaDrive is the real turning point and Tesla will win this race, comment number 1. If this video brought you value, hit like and share it with people you think would want to know about it. Subscribe to the channel to follow the next developments in this story because I promise you, this story is not over, it has only just begun.